Welcome back, everyone, to Product Lore. Today, we're going deep on a new large language model, or LLM, that's been making some serious waves in the AI world. It's called DeepSeek-R1, and it's an open source model, so anyone can access it and use it. Now, you might be thinking, okay, another LLM, what's the big deal? Well, this one is different, and it's different because of the way it was trained. DeepSeek-R1 was developed with a heavy focus on reinforcement learning, which is a really powerful technique for training AI. And that's resulted in an LLM with some pretty impressive reasoning abilities.
Yeah, it's really exciting stuff. Reinforcement learning has already been used to create some amazing AI systems like AlphaGo, which beat a world champion Go player, and AlphaFold, which cracked the protein folding problem. Now, DeepSeek is kind of taking that same approach and applying it to LLMs.
Okay, so let's back up a bit for those who might not be familiar with how these LLMs are typically trained. Before DeepSeek-R1, there was a kind of standard three-stage process, right?
Yeah, you've got it. So traditionally, you start with pre-training, and this is where you basically feed the model massive amounts of text and code data. It's kind of like cramming for an exam, but on a superhuman scale.
Gotcha. So it's like giving the model a foundation of knowledge.
Right. And then you move on to supervised fine-tuning. And this is where you give the model specific instructions and examples to teach it how to perform certain tasks. It's like you're showing it the ropes and guiding it towards the desired behavior.
And then the final stage is reinforcement learning, right?
Exactly. That's where you really fine-tune the model's behavior by rewarding it for making good decisions and penalizing it for making mistakes. It's kind of like training a dog.
Oh, I get it. Like giving it treats when it does something right.
Exactly. You're shaping its behavior through a system of rewards and punishments. And over time, it learns to maximize those rewards.
So that's the traditional approach.
Yeah.
But DeepSeek-R1 decided to shake things up a bit, didn't they?
They did. They actually either skipped or minimized that supervised fine-tuning stage and went all in on reinforcement learning.
So instead of giving it a bunch of instructions, they basically just let it learn from its own experiences.
Well, it's a bit more nuanced than that, but yeah, the idea is to let the model figure things out more on its own through trial and error and feedback.
I see. So how does this reinforcement learning magic actually work in DeepSeek-R1?
Well, they started with a version called DeepSeek-R1-Zero, which used something called rule-based reinforcement learning. Imagine you're playing a game with a set of rules. The model's goal is to win the game by following those rules and maximizing its score.
Okay, so it's like there's a scoreboard and the model gets points for doing things right.
Exactly. And the researchers designed those rules and scoring systems very carefully to encourage the model to develop strong reasoning abilities.
So it's learning by playing this game and trying to get a high score.
That's the basic idea. Now, what's really cool is that even with these relatively simple rules, DeepSeek-R1-Zero started to exhibit some pretty remarkable behavior during training.
Like what kind of behavior?
Well, one thing they noticed was that the model started to dedicate more of its processing power to solve complex problems as training progressed. It's like it realized, hey, I need to think harder about these tough questions if I want to get more points.
Wow, so it's kind of adjusting its own learning strategy.
In a way, yeah. And there's even evidence that it started to have aha moments during training.
Aha, moments. What do you mean by that?
Well, there's this one example in the paper where the model was working on a math problem. And it seemed like it got stuck for a while, but then suddenly it backtracked and reevaluated its previous steps, and then it was able to come up with the right answer.
So it's like it had a flash of insight, like it suddenly understood something it hadn't before.
Exactly. And those kinds of aha moments are really exciting because they suggest that the model is starting to develop more sophisticated reasoning abilities.
That's pretty wild. But wait a minute, if this DeepSeek-R1-Zero was so smart, why even bother creating DeepSeek-R1?
DeepSeek-R1-Zero was a major breakthrough, but it did have some quirks. Sometimes it struggled with readability, and there were even instances where it would mix languages in its responses.
Oh, yeah. I can see how that would be a problem.
Yeah.
Especially if you're trying to use it for something like generating text or translating languages.
Right. So DeepSeek-R1 was kind of a refinement of that initial model.
So how did they fix those issues in DeepSeek-R1?
Well, they did incorporate a small amount of supervised fine-tuning to address those quirks.
So they went back to the traditional approach after all.
Not exactly. They used a very clever technique called cold start data.
Yeah.
Basically, they took some of the best, most readable responses that DeepSeek-R1-Zero had generated and use that as a starting point for training DeepSeek-R1.
Okay, so it's like giving it a head start with some high-quality examples.
Exactly. And then they combined that with more reinforcement learning to further refine the model's behavior.
So they're kind of blending the best of both worlds.
That's a good way to put it, and the results are really impressive.
So tell me more about this training process.
Well, on top of the cold start data, they used 4 distinct phases of training.
4 phases. Wow, that sounds intense.
Yeah, it is. But it really highlights how much thought and effort went into creating DeepSeek-R1.
Okay, so walk me through those phases. What happens in each one?
So after that cold start, the second phase is called reasoning reinforcement learning.
Makes sense.
And in this phase, they really focus on honing the model's reasoning abilities.
So like giving it lots of math problems and logic puzzles to solve.
Exactly. And they still use those clear rule-based rewards we talked about before.
So the model's still playing that game, trying to get a high score by solving those problems correctly.
Right. Now, the third phase is where things get even more interesting. It's called rejection sampling and supervised fine-tuning.
Rejection sampling. What's that all about?
It's basically a way of filtering out the bad responses and keeping only the good ones.
Like a quality control process.
Exactly. Imagine a factory that's producing toys, and they have a team of inspectors who check each toy to make sure it meets certain standards.
Right. The ones that pass inspection get shipped out, and the ones that fail get rejected.
That's pretty much what's happening in this phase.
So DeepSeek-R1 is generating a bunch of responses, and then there's this inspection process that decides which ones are good enough to keep.
You got it. And they even use a special AI model called a generative reward model to help with this selection process.
Wow, so they're using AI to train AI.
That's right. And it's really effective.
Okay, so we've got the cold start, reasoning, reinforcement learning, and rejection sampling. What about the final phase?
The fourth and final phase is called diverse reinforcement learning. And in this phase, they really focus on making the model more helpful and user-friendly.
So it's like taking all that raw reasoning power and shaping it into something that's actually useful in the real world.
You got it. They give the model a wider range of prompts, and the rewards are designed to encourage it to generate responses that are informative, relevant, and easy to understand.
So it's like fine-tuning the model's personality, so to speak.
Yeah, that's a good analogy.
So this whole 4-phase training process is what makes DeepSeek-R1 so special. It's a reasoning powerhouse that's also user-friendly.
Absolutely. And the DeepSeek team didn't stop there. They wanted to share their findings with the wider AI community. So they used a technique called distillation to create smaller, more accessible models based on their work.
Distillation. That sounds interesting. Tell me more about that.
Think of it like a master chef teaching their apprentices their secret recipes.
Okay.
They take their complex knowledge and skills and break them down into simply steps that are easier to follow.
Interesting.
That's kind of what distillation does with AI models.
So they're essentially sharing their expertise with the world.
Exactly. They've created these distilled versions of DeepSeek-R1 that are based on existing open source architectures like Llama and Qwen. And these distilled models are much smaller and easier to run, so even researchers with limited resources can experiment with them.
That's fantastic.
Yeah.
It really democratizes access to this cutting-edge AI technology.
It does, and I think that's one of the most exciting things about DeepSeek-R1.
Okay, so we've talked a lot about how DeepSeek-R1 was trained, but how does it actually perform compared to other LLMs out there?
That's a great question, and that's what we're going to dive into next.
Buckle up, everyone. It's about to get interesting.
All right, so let's get into those benchmarks and see how DeepSeek-R1 stacks up against the competition. One of the areas where it really shines is math. And the researchers put it through its paces on some pretty tough challenges.
Yeah, I was looking at the paper and they tested it on the AMY exam, right?
That's right, the American Invitational Mathematics Examination. It's a super challenging exam for high school students. Even getting a single problem right is a big deal.
So how did DeepSeek-R1 do? Did it pass with flying colors?
It crushed it. It achieved an accuracy of 79.8% on the AMY 2024 exam.
Wow, almost 80%. That's incredible.
Yeah, it's really impressive. And to put that in perspective, that score even beat OpenAI's O1-1217, which scored 79.2%.
So it's outperforming one of the leading LLMs from OpenAI on a challenging math exam. That's a big deal.
It definitely is, and it really highlights the power of this reinforcement learning approach.
Did they test it on any other math benchmarks?
Oh yeah, they didn't stop there. They also tested it on the Math 500 benchmark, which covers a wide range of undergraduate level math problems.
So we're talking about college level math here, not just high school stuff.
Exactly. And DeepSeek-R1 aced it with a near perfect accuracy of 97.3%.
97.3%. That's insane. So it can handle high school math and college-level math. What about coding? You mentioned earlier that it excels there too.
Absolutely. They tested DeepSeek-R1 on Codeforces, which is a popular platform where competitive programmers from around the world battle it out.
Oh yeah, I've heard of Codeforces. It's like the Olympics of coding, right?
Pretty much. And you're going up against some of the best human coders in the world.
So how did DeepSeek-R1 fare in this coding arena?
It held its own, and then some. It achieved an ELO rating of 2029.
ELO rating. Remind me what that is again.
It's basically a way of measuring a player's skill level.
Gotcha. So the higher the ELO rating, the better the player.
Exactly. And an ELO rating of 2029 puts DeepSeek-R1 in the top 3.7% of all Codeforces participants.
Top 3.7%. So it's basically a coding grandmaster.
You could say that. And it's not just about competitive coding either. They also tested it on Live Code Bench, which focuses on real-world coding tasks.
So more practical stuff that you might encounter in a software development job.
Right. And again, DeepSeek-R1 performed really well, getting an accuracy of 65.9%.
How does that compare to other LLMs?
Well, it beat OpenAI's O1-1217, which scored 63.4% on the same benchmark.
Okay, so it's outperforming OpenAI in coding as well. This DeepSeek-R1 is starting to sound pretty unstoppable.
It's definitely impressive, but it's not just about math and coding.
Right. What about more general knowledge? Can it answer trivia questions or understand different subjects?
They tested that too. They used a benchmark called MMLU, which stands for Measuring Massive Multitask Language Understanding.
Oh, that's a mouthful.
It is.
Yeah.
But it basically tests a model's knowledge across 57 different subjects.
57 subjects. That's like a decathlon for AI.
You got it. And DeepSeek-R1 did pretty well in this mental marathon, scoring an accuracy of 90.8%.
So it has a pretty broad understanding of all sorts of things.
It does. No, it did score slightly lower than OpenAI's O1-1217, which got 91.8%.
Okay, but still, that's really impressive for an open source model.
Definitely.
So it sounds like DeepSeek-R1 is a pretty amazing LLM. But let's be real for a second. No model is perfect.
It's true. Every hero has its weaknesses.
Exactly. Are there any limitations to DeepSeek-R1 that we should be aware of?
That's a great question, and I'm glad you brought it up because the researchers are very upfront about the limitations of their model in the paper.
Okay, good to know. What are some of the things they highlight?
One thing they mention is that DeepSeek-R1 can sometimes mix languages in its responses.
Oh, really? Like it'll start a sentence in English and then suddenly switch to Chinese?
Sometimes, yeah. It seems to happen more often when it's dealing with languages other than English and Chinese.
I guess it's like trying to juggle too many languages at once.
Yeah, you could say that. They tried to address this during training, but it's still an area for improvement.
So language mixing is one thing to watch out for.
Yeah.
Are there any other limitations?
Another thing is that it can be a bit sensitive to the way you phrase your questions.
Interesting. So how should you phrase them?
It seems to do best with clear and concise prompts. Like, if you want it to write a poem, you should tell it directly. Write a poem about nature.
Don't beat around the bush.
Exactly. Be direct and specific. And one more thing.
Okay, what's that?
DeepSeek-R1 hasn't been extensively tested on really complex software engineering tasks.
So while it's great at coding challenges, it might not be ready to build the next big app just yet.
Right. It's more of a coding prodigy than a seasoned software engineer at this point.
Makes sense. So there's still some room for growth.
There is. But the good news is that the DeepSeek team is aware of these limitations, and they're actively working on solutions.
And the fact that they're sharing these limitations openly is a good sign.
It is. It shows that they're committed to transparency and that they want to help the entire AI community learn and grow.
I agree. It's refreshing to see that kind of honesty in the AI world. Now, I'm curious, what are your thoughts on the bigger picture here? What do you think the success of DeepSeek-R1 means for the future of AI?
That's a big question. But I think it's a really positive development. You know, it's not just about the impressive capabilities of DeepSeek-R1 itself. It's about how they got there. By focusing on reinforcement learning and making their work open source, DeepSeek has shown that you don't need to be a tech giant with unlimited resources to create powerful AI tools.
That's a really important point. It democratizes AI and opens up so many possibilities for innovation.
Exactly. And that's why I'm so excited about DeepSeek-R1. It's a sign that the future of AI is going to be more collaborative and accessible.
I love that vision. So what's next for DeepSeek-R1? Did the researchers share any insights into their future plans?
They did, actually. There's a whole section in the paper dedicated to their unsuccessful attempts.
Unsuccessful attempts? Really? Why would they include that?
It might seem strange, but it's actually incredibly valuable. By being transparent about what didn't work, they're helping other researchers avoid those same pitfalls.
So it's like they're sharing their lessons learned.
Exactly. It's
Yeah.
all about advancing the field of AI as a whole.
That makes sense. So what were some of the approaches that the DeepSeek team tried but ultimately abandoned? I'm curious to hear what didn't work.
One interesting approach they explored was using something called a process reward model, or PRM. Imagine a teacher grading a student's work as they go along, step by step. That's kind of what they were trying to do with the PRM.
Oh, I see. Providing feedback during the reasoning process itself.
Exactly, but it turned out to be much harder than they expected.
How so?
Defining what makes a good reasoning step is tricky because reasoning is so context-dependent.
Right. What might be a logical step in one situation could be totally wrong in another.
Exactly, and then there's the question of how do you evaluate those reasoning steps? Having another AI model do it automatically isn't always reliable, and having humans do it manually would just be way too time-consuming with so much data.
So they were stuck between a rock and a hard place.
Pretty much. And there was one more issue they ran into with PRM, something called reward hacking.
Reward hacking. That sounds kind of ominous. What is that?
It's when the model figures out how to game the system to get those rewards without actually learning the desired behavior. It's like a student figuring out how to cheat on a test without actually understanding the material.
So it's finding loopholes and shortcuts.
Right, exactly. So the PRM approach had all these challenges and they had to abandon it. What else did they try? Let's see. They also tried using a technique from the world of game-playing AI called Monte Carlo tree search, or MCTS for short.
Now, MCTS has been used to create some really impressive AI for games like Go and Chess Right.
Yeah, exactly. So how did they try to apply that to LLMs? Well, they wanted to use MCTS to break down these complex reasoning tasks into smaller steps and then explore different paths to a solution.
So it's like the model is navigating a maze, trying to find the best route to the answer.
That's a good analogy. And to guide this exploration, they used a pre-trained value model that could estimate how good each reasoning step was.
So they had this separate AI model acting as a guide, helping DeepSeek-R1 make the right moves.
Exactly. But they ran into a few problems. First, the world of language and reasoning is so vast and complex compared to a game like chess. The number of possible reasoning paths can just explode, making it really hard for MCTS to explore all the options efficiently.
So it's like trying to find a needle in an infinitely large haystack.
Right. And then there's the issue of the value model itself. Training an AI to accurately judge the quality of a reasoning step is super difficult.
Yeah, it's like trying to teach a computer to understand nuance and context.
Exactly. And if the value model isn't reliable, it can lead the MCTS down the wrong path.
It's like having a faulty compass.
Right. So in the end, those challenges proved to be too much, and they had to abandon the MCTS approach as well.
It's amazing how much trial and error goes into this kind of cutting-edge AI research.
It really is. And it just goes to show how difficult it is to create AI that can truly reason like humans do.
Well said. It's been fascinating exploring the world of DeepSeek-R1 with you today, from its impressive reasoning abilities to the challenges the researchers faced along the way.
I agree. It's been a great discussion.
And for all our listeners out there, this deep dive just scratches the surface. We encourage you to check out the full research paper for all the technical details. We'll include a link in the show notes.
And if you're interested in learning more about products, trending technologies, and AI applications, we have some great content lined up for our listeners.
Thanks for that. And be sure to tune in next time for another deep dive into the world of cutting-edge technology right here on